For this circuit we need to find the voltage drop V1 and V2. Now if we look at the circuit, we can see that there is a delta connection here. This one is a delta connection, and it will be convenient to solve if we convert this delta into Y. Now when we do that, what happens is, if we recall Y delta conversion, this will be like this. So that's the circuit there, and here we have, so first I will probably draw here. Here we have a delta. When we convert it into Y, it becomes, there is, maybe I will use a totally different color, maybe a reddish one. So this becomes, this is one resistance, this is basically, this is one node of the delta, this is another node, and this is the third node. So in each of the nodes in delta, two resistances are connected, but when we convert it into Y, there will be only one resistance. So this is the resistance here, then there will be a resistance here, and there will be another resistance there. So this is a resistance, sorry, that one there. So this, the value of this resistance will be, the way the conversion is done, this resistance value will be multiple, the product of these two resistances, the two resistances that were connected to the same node in delta, that two, the product of those two divided by sum of all three. So here when we convert into Y, so that will be, if I draw like that, what I can do, I can also label them, so that probably is better. So this is the 40 ohms and that's the 50 ohms, and here we have node A, node B and node C, and this is also node A, this is node B now, and this is node C. So to know node A, at node A the resistance, 1 ohms resistance and 15 ohm resistances are connected in delta. So in Y, the resistance that will be connected to node A will be, the value will be 15 times 1 divided by sum of all three. So 15 plus 1 plus 10. So that's 15 over 26. So that will be this value, 15 over 15 over 26. Similarly at node B, resistance 1 ohms resistance and 10 ohms resistance, these two are connected. So the Y equivalent value will be 10 times 1, because these two are connected in delta, divided by again sum of 3, so that's again 26. So that will be 10 over 26. And finally at node C is connected, node C in delta, the two resistances that are connected are 15 ohms and 10 ohms. So 15 times 10 divided by 26, that will be the equivalent Y value. 15 times 10 divided by 26, so that's 150 over 26. So these are the three resistances. Now what we can see here is, this is now becoming a simple, we have to find V1 here and V2 there, and these two can be found by using voltage divider rule. So V1 will be, of course, 24 divided by sum of these three resistances, so 40 plus 15 over 26 plus 10 over 26. So if I write the sum, so 15 over 26 plus 10 over 26 will be 25 over 26 and times 40. So this is just the voltage divider rule. This is the total voltage that is from here to here we have, and we want to find just V1, which is across 40, that's why we are multiplying by 40, and here sum of three resistances. Here this one is just sum of these two resistances together. So when we solve that, what I got is 23.43 volts. Similarly V2 will be 24, again same voltage, so we will have now these three resistances, this one and this one. So 50 plus 15 over 26 plus 150 over 26. So 15 over 26 plus 150 over 26, and times will be 50 because across 50 ohms resistance we want to find the voltage. So that is 24 there. 50 plus 165 over 26 times 50. So what I get there is 21.3 volts. So these are the two resistances, and what we have done in this problem is actually we have applied voltage divided rule. That's later. We have actually done a delta to Y conversion in this problem.